Welcome back. My name is Sanjay, and today we'll learn how Python memory management is done. So to understand this, we will use this picture. So for example, let's say I have a variable x equals to 10 and y equals to 10 and z equals to 10. So in Python, a value will have only one copy in the memory and all the variable having this value will refer to this memory location. For example, here in the computer memory we will have only 10 and all the variables x, y and z will refer to the same memory location. So we'll try to see in the Python editor. So here let's say x is equal to 10, y equals to 10, z equals to 10. We'll try to see the ID of x. When I say ID of x, it gives me the memory address of x. So ID of x is 193037075504. Similarly, if I try to print ID of y, here we see ID of x and ID of y is same. Similarly, if I say ID of z, this is also same. So this means when we create a variable and it has some value, and if I create another variable and if it holds the same value, the the memory location would be same and the variable will point to the memory location. If I increase x by 1, right? In this case, now if I try to print ID of x, it would be different. Still, if you see ID of y and ID of z, it would be still same. So when I say ID of any variable, it gives us the memory location address. So in this picture, we will have another location created where value would be 11 and y would point to the 11, right? Like this. So here our y will come and this would be deleted. This is how Python manages its memory. Let's try to understand with another example. Let's say I have a is equal to 500 and b which is equals to again 500. And now if I try to print ID of a and ID of b, theoretically it should be same, but in this case it won't be same, it would be different. See here, this ID and this ID is different because this rule is applicable only till -5 to 256. So this rule is applicable from -5 to 256. Let's try to see with an example. Let's say I have to -5, y equals to -5. So if I try to print ID of x and I try to print ID of y, these two are same. So it means uh, -5 is stored at one place and x and y is pointing to the same memory location. Let's try to take another example. A is equal to -6, b equals to -6. Let's try to print the ID of A and B. ID of A, ID of B. It is different. So it means the rule is applicable from -5 till 256. Let's try to take the example of 257. So I have x is equal to 257, y equals to 257. Let's try to print id of x, id of y. Here IDs are different, so memory locations are different. So x is stored into different location and y is stored into different location. Let's take another example, and this time we will use string. For example, I have a string s1. Don't worry about this. We will learn string, list, everything later point. So we have s1 hello, s2 hello. Let's try to print the ID of S1, ID of S1. Let's try to print ID of S2. So both has same ID. So in case if I print S1 double equals to S2, so this will give me true because both the ID is same. The values are same. Even though if I say S1 is S2, it is also true because S1 and S2 is stored in the same memory location. Let's try to take another example S3. Hello world. S4. Hello world. Let's try to print the IDs. ID of S3. ID of S4. Both are different because this is out of the limit. Hello world. This string is out of the limit. So we can say S1 equals to S2. It's true because the content is same. Here S3 and S1. Oh sorry, here we will take S3 double equals to S4. S3 double equals to S4. S3 and S4. Here the content is same. Hello world. So that's why the output is true. Let's try to say S3 is S4. Here it is false because the memory location is different. So here we can say if we use double equals to, it will compare the content. But when we use is operator, it will compare the memory location, the memory address. Anyway, we will learn this later in deep. If you see, Python is using same memory location for string hello, but it is using different memory location for string hello world and exclamation marks. So this is called entering. So this operation for this hello, it is taking the same memory location. For this hello world, it is taking different memory location. This process is known as entering in Python. Let's try to learn why Python is dynamic and strongly typed. So when I say x is equal to 10, here I don't define int x is equal to 10. Still Python automatically understands that it's an integer. To check that, you can use type of x. This will give you result class int. It means Python automatically understand that this variable is integer. This value is integer. That's why Python calls dynamic type, because dynamically it will understand what is the type of the value given. Now let's try to learn why Python is strongly typed. For example, I have one variable called y equals to India. Now let's try to do x plus y. So x is equal to 10 and y equals to India. So if I try to add x and y, it will give me an error. This happens why? Because x is integer type and y is string type. And in Python we cannot add string with integer. That's why Python is known as strongly typed. It will, if we want to add, we need to convert integer to string. In this example, we can say str of x plus y. So what we are doing here is we are explicitly converting integer to string plus y is already string. So we can add this. This is possible. So this proves that Python is dynamic and strongly typed. Thanks for watching. Have a great day.